Okay, this is Module 16, Apply Other Angle Relationships in Circles. In this part of the module, you are going to be doing a lot with formulas. So basically, keeping track of those formulas is going to be important, and maybe possibly making flashcards to help you study those is going to be important as well. So the first thing I have is relation to another module, a previous module. I ask, what is this particular angle called from the previous module? And the correct answer is, this is an inscribed angle. And the inscribed angle has the intercepted arc here. Well, if I took this same inscribed angle and just kind of shifted it on its side here, basically the exact same thing is created, and the same formula to actually find out what the intercepted arc is as well is used. So in this case, I have my intercepted arc here, kind of like the inscribed angle, only the inscribed angle is on its side. So there's your vertex of your inscribed angle, there's your intercepted arc. So it's identical in terms of how we actually find the measurement. So the theorem that you need to know is, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So there's your formula, and basically you have measure of arc AB, whatever that may be, which is this arc right here. Whatever that is, you times it by 1/2 to get the actual angle that's created by the tangent and the chord. Okay, so here's an example. So I have my tangent line and my chord, and the intercepted arc that's created is this intercepted arc right here. And we know that it is 284, so to go from the intercepted arc to the actual angle, all you do is do 284 divided by 2. So measure of angle 1 equals 142 degrees. And that's it. Okay, so this next one, people get mixed up with the following three. So again, keeping these in order straight is important. And in this case, I have an angle inside the circle theorem. If two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the angle, or of the arcs intercepted by the angle. So if I have my interior angle here that I'm given, if I take this intercepted arc, which is one of the intercepted arcs by the two chords, and then I take another intercepted arc, let's go with green just to make sure, the other intercepted arc, which is BD, if I sum those two together and times it by 1/2, it will actually give me the measure of the angle 1, which is created. So I have my BD arc measure, and I have my AC arc measure. Now the thing to keep in check is that it has to be the angle that's created that is opposite each one of the intercepted arcs. So like here and here. It can't be this angle, because then that would be denoting AB's arc here and CD's arc. You would use the same formula, but just with two different arcs. So just be careful of what you are actually given. So in this case, I'm given angle 1, so that means the angle or the arc to the left, the vertical angle here, and the arc to the right. So here's your application. If you want to pause the video and try and see if you can actually do it, by all means. If not, I'm going to kind of go through it. And this one is a little bit tricky, just because, again, we're looking at all these central angles, inscribed angles, all that stuff, so keeping them straight, it can be a little bit tricky. So we have the two intercepted parts here, so it'd be 1/2 the addition of 58 plus 72. That equals measure of angle 1. So when you do this, we get 65 degrees equals the measure of angle 1. And we're done. That's it. So add the two arcs that are intercepted together, divide it by 2 or times it by 1/2, and that will give you the actual angle measurement that's given here. And again, don't forget vertical angles, because that angle measurement here can be found. Okay, the next three formulas are going to be identical in terms of the formulas, but the figures themselves are going to vary just a little bit. So the thing that I tell people is, remember, outer minus the inner times 1/2. And that's for the following three theorems. So I have angles outside the circle theorem. If a tangent and a secant line, so I have a tangent line and a secant line, intersect in the exterior of a circle, so there's my exterior intersection, then the measure of the angle formed is 1/2 the difference, the measures of the intercepted arc. So we have outer minus inner times 1/2. So you have to identify what your outer arc is. So in this case, my outer arc is this guy right here. That's my outer arc. Then you have to find out what your inner arc is. So your inner arc, again, is between the secant and the tangent. So here's your inner arc here. So whatever those angle measures are, you do basically the red minus the purple. So the formula is as follows. So we have outer minus inner times 1/2. So the measure of AC and the measure of BC, the difference between the two. Okay. So in this one, what typically people do is they look and see, okay, I have 134 and I have 12. Well, the problem is you have to identify what your outer and your inner is. So we have your inner is 134. Most people get that. But the problem is people think that your outer one is 12 because it's outside. That's not the case. It's actually, remember, the inner and the outer have to be between the two tangent and secant line in this case. So the outer is actually this arc right here. So in this arc right here, we actually don't know. We can call it x. But all three of these angles, this one, and this one, add up to what? And the correct answer is 360 degrees. So we have x plus 134 plus 12. And if you solve, set it equal to 360, you get x equals 214. Okay, so 214, that is this guy here, so that means you have 214. That means now you have your outer minus inner times 1/2. So outer in this case would be 214 minus your inner, which would be 134, times 1/2 gives you the measure of angle 1. So measure of angle 1. And when you do this, measure of angle 1 gives you 40 degrees. Okay, next one. In this case, the only difference is now you have, instead of a tangent and a secant, now you have two tangents. So if we have two tangents lines intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So again, the same exact formula, outer minus inner times 1/2. So we have the outer in this case. There's your outer. And your inner in this case is going to be arc AB. So here's your inner. And again, times that by 1/2. So when you do that, look at what they give you and then just plug it into the formula, because sometimes algebraically it can be tricky. So here we go. Now looking at this, most people say, okay, well, I got the inner. That's pretty easy. That's pretty straightforward. The outer one kind of eludes them a little bit. The outer one you have to think back to algebra. If I have the entire inner part is x, the outer part plus the inner part have to equal 360 degrees. So if they equal 360 degrees, you can write this as 360 degrees minus your x to figure out your outer. So once you have that, then you do, again, outer, 360 minus x, minus your inner, times 1/2. That equals your exterior angle, which is 45 degrees. Okay. Algebraically, if you solve, you can multiply by 2 on both sides to get 360 minus 2x equals 90, because I multiply by 2 on both sides to get rid of the 1/2. And then solve, you should get x equals 135, because that's what I'm asked to solve for. And that's it. So we just had secant and a tangent. These are two tangents. The next one is going to be two secants. So in this case, again, the exact same thing, outer minus inner times 1/2. So we have two secants lines intersecting the exterior of a circle. Then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So here again, we have our outer edge arc, which is BD, and then we have our inner arc, which is AC. Okay, outer minus inner times 1/2. So identify what your outer arc is, what your inner arc is. Okay, so again, here's our figure. We have our outer arc here, and you have your inner arc here. So again, we do outer minus inner times 1/2. And that equals measure of angle 1. So in this case, 24.5. Okay, so here are mixed examples. I'm not going to provide or work through these, but I will give you the answer of each one of these. If you do them correctly, you should get the measure of angle 1 equals 148. If you do this one correctly, you should get the measure angle 1 is 33 degrees. Try 1/2 degrees. If you do this one correctly, you should get value of x equals 125. And you can put degrees or not, it doesn't matter because it's actually in the value of x. Measure of angle 1 is equal to 39 degrees. That's it. So outer minus inner times 1/2.